Hello, welcome to another lesson of sectoral structures theory. We are using the book with the title Sectoral Structures Theory. In the last lesson, we talked about the difference between the intersection of two sets or two sectoral sets, and we introduced the concept of commonality between two sectoral sets, where intersection is the regular definition, which are the elements common to both sets. We said that commonality refers to the elements or the sectoral structures that are not shared by the two sets, but are isomorphic to one another. Um, Also, if they are shared, they are still included as part of the commonality, but that's the broader definition. Now for union, we know that the union of two sets, as we see by the Venn diagram, basically includes all the elements that are in A but not B, all the elements that are in B but not A, and the ones that are common to both. Now, when we expand this concept into sectoral structures theory, we have to introduce the idea similar to union, but it is a little bit unique. We will use this symbol right here, and we will call this the merger or the merging of two sectoral sets. So let's say we have these two sets, A and B, and let's say they don't have any common elements. If we were to take the union, it would simply be every element in A and every element in B. If we want to take the merger of the two sets, we will say A merge B. And let's say there are subsets in each of these that are isomorphic to each other. So let's say there's a C here and a D that are isomorphic. If we were taking the regular union, it would include all the elements of C and all the elements of D as separate elements. However, if we want to take A merge B, it will be all the elements in A that are not isomorphic to B, all the elements in B that are not isomorphic to A, and we include one subset of elements that are isomorphic. So basically, you can think of it either as we're only including one of the two isomorphic subsets, or another way to think of it is that we are removing one of the two isomorphic subsets from the union. Quick example, let's say we have the sectoral set ST2, which includes 1 squared 2 and 2, 2. And we have the sectoral set ST3, which includes 3, 3, 2, 1, 3, and 1 cubed 3. If we were to take the union, we would include all of these elements. So we would have 2 elements here, 3 elements here, and we would have a new set with 5 elements. However, when we do the merging or the merger of the two sets, of the two sectoral sets, we will include first all the unique elements. So 1 squared 2, 2, 1, 3, and 1 cubed 3. But then we are left with the two theta structures, 2, 2, and 3, 3. And we can only include these or count these as a single element. So one way to write it would be like this, 2, 2, isomorphic to 3, and include it as one element. Alternatively, we can just say, because it's a theta structure, we'll just say theta without specifying. But here we have 1, 2, 3, 4 elements. So we've lost one element from the union. More broadly, X merge Y for two sectoral sets is the set of all sectoral structures that where AN, the sectoral structure, either fits in X or fits into Y. So this is a more broad definition. We've seen earlier when we compared intersection and merger and commonality, that the size of the commonality set is either equal to the intersection or greater. So for example, here we have this more complicated situation. We have A and B, we have the intersection of A and B, and we have two subsets that are isomorphic to each other. So if we're looking at the intersection, it will be only this area here. If we look at the commonality, it will be this area plus the commonality between these two subsets. Now, on the other hand, when we look at the merger, it's the opposite. So it is equal to or smaller in size than the union of the two sets. So the merger would include the entire union minus one of these two subsets. So that's one way to distinguish between the two concepts or the two sets of concepts. Let's define it again. So A common B is equal to A intersection B plus or union the isomorphism between C and D. And here we're talking about sectoral isomorphism. And that's why it is always bigger or equal to the intersection. On the other hand, A merge B is equal to A union B minus this isomorphism between these two sets. So it will be smaller in size. Now, last time we defined, if you remember, of course, meem of n is equal to the size of the sectoral set STN, just a quick reminder. And we said that the size of the commonality between two sectoral sets is equal to, or we used meem star, and we said it is equal to meem of the greatest common divisor of n and m, and we used the symbol meem star nm. Now, when we want to find the size of STN merge STM, we will use meem plus. So instead of meem star, we will use meem plus n comma m. And we will find that meem plus of nm is equal to meem of n plus meem of m minus meem star of n comma m. So this is really similar to how union and intersection work, except we're using the meem function here. Let's look at some of the special situations. Let's say we have two sectoral sets, STN and STM, where n is a factor of m. So for example, we have the set ST4 and the sectoral set ST2. Here we have a situation where there is a subset in STM that is isomorphic to the entirety of the other set STN. So for this reason, we will say that STN merge STM in this situation will be equal to STM. Now, another situation which is similar to what we saw earlier, where the isomorphism is only one element, meaning there's only one isomorphic sectoral structure, and it would usually be the theta structure. In this case, we will say that STN merge STM is equal to the union of STN and STM minus that single theta structure. But more broadly, for any two sets, we will say STN merge STM is isomorphic to, I shouldn't say equal, I should say isomorphic to STN union STM minus the commonality. So I hope this makes sense. So in this lesson, we introduced another twist on the idea of union of sets. In the last lesson, we saw a little bit of a twist on the intersection of sets. So in the setting of sectoral structure theory, we have two different types of unions, union and merger, and we have two different types of intersections, which are intersection and commonality. Thank you.